Hello everyone, I am Shreya Dijiti and I am pursuing MS in Computer Science with specialization in data science from University of Southern California. Before my master's, I completed my undergrad in information technology, and after completing my undergrad, I worked as a software engineer at Samsung Research India for 3 years. I have created this project for the course that I am taking this fall, that is DSCI 551. So this project is an EDFS application, that is emulated database file system, distributed file system. And in order to implement this, I have used a Firebase real-time database. So I have used Firebase as it is a cloud-based NoSQL database that lets you store and sync data between users in real time, and it is very easy to use, uh, and implementing directory structure and storing files is very hassle free in Firebase. And for the programming languages, I have used Python because handling CSV and JSON files is very easy in Python. Uh, and I have implemented the entire project on Jupyter Notebook. And for to implement my UI, I have used Python package tkinter. Uh, and the UI of my application uh, looks like this. So, the implementation details are as follows. So I have implemented the commands such as mkdir, and before letting you know what mkdir does, let me show you how to implement it. So we can do like mkdir/user/Shreya. Before that, the current directory structure looks like this. So there is a directory root which contains a directory user and which contains a directory John. So if we run this command and we refresh it, we can see that a directory Shreya has been created under user. So mkdir is basically used to create directories in our directory structure. So the next command is excuse me. So the next command is ls. So again, we'll see the implementation of that first. So this is ls/user/John slash, and then we'll see that John has a data.csv file, and that file has been listed. So ls is used to list all the files that are in a particular directory for which the path has been given. And the next is RM. So we can implement it as RM/user/Shreya, and it says that /user/Shreya is successfully deleted. And when we refresh this, we can see that when we refresh this, we can see that Shreya no longer exists. That means it has been deleted. So RM is used to delete the directories and files in our directory structure. And the next command is the cat command. So when we try to implement cat, we see that /user/John/data.csv. So it's going to take some time. So here we can see that whatever data was present in data.csv file, it has been displayed. Therefore, cat is used to return the contents of a particular file. And the next function is put. So we will let's look at the implementation of put. So put is kind of a function. It takes three arguments. First is the file name. So I have a file, uh, uh, the cut id.csv, and I want to put this file to a particular partition, to a particular directory, which is /user/John, since we just have John over here. And then I want to give it number of partitions, so I'm giving it 6. So let's see what happens. Oh, so there's a missing semicolon. Oh, there's a missing colon over here. So so Oh, this should work. So as we can see that this has been uploaded to the file system in 6 partitions. So when we refresh this, we can see that cut id.csv is present here. So put command is used to add a particular file to our whichever path we want. We can pass that path and we can put this file in that path, and these are the number of partitions. So the number of partitions are is the number of partitions that this file is going to be divided into, and then it's going to be stored in our database. So next is get partition locations. So if get partition locations, as the name suggests, is a function that will return the partition location of our of any of the file that we pass. So suppose we pass /user /john /data.csv. So this is, suppose you want location of all the partitions of this file. Uh, oh, there's a extra full here. Sorry. So it has returned all the partitions that existed for data.csv. And our next command is read partition command. So we can read partition is used to read the partition that are read up any particular partition for a file. So it's going to take 2 arguments. First, the file that we want to read. So if you want to read /user /john /data.csv, and we want to read partition number 3, so we can give it like this, and then it's going to just display all the contents of the file that are present in that particular partition. So we can also look at the code of this of all these commands that I have implemented. So this is mkdir command, and mkdir command is used to create the directory, as I have shown you earlier. So what I'm to implement this, what I've done is I've taken the database endpoint, which is the the URL of my Firebase database that I am using. And as the user passes the directory path as an argument, so I'm going to split all the directories by this slash. And then I'll check if the directory 0 is equal to this. That means the root does not already exist. So I'm going to add root, and then for the other directories, I'm simply going to add a slash to it, and then just check if the database already has it. If a database does not have them, that is r.json is equal to none, then I'm going to use this patch command and then simply add it to the database. And since these are mkdir creates the directory, so these are going to be the directories. So I'm going to add the file type as the directory for all of these. So the next function is the ls. Ls is used to list the files that are present in any of the directory, as I have shown you earlier. So to do that, what I'm going to do is I'm going to send a get request to our database and check if there is any response. If there is no response, then we can say that the particular directory does not exist and the path might be raw. Otherwise, what I'm going to do is I'm going to simply check the path of the directory, and if the file type is directory, then I'm not going to return it. Otherwise, I'm going to just append it in a list, and then I'm going to return the list of those files. Second is remove directory. So remove directory or remove file. So what I'm going to do is I have to put I am not since in the database we cannot store a file as dot, so I'm going to use mod instead of dot over here, and I'm going to use path.rfind for this dot. So if in this path this exists, so I'm going to simply replace it with this right here. And then I'm going to check with a get request that if this path exists or not. If this path does not exist, that is, this directory does not exist, we will simply print that no such file or directory is present, and we'll return the function. Otherwise, what we are going to do is we just go to that directory, and we are going to delete it from our database. And then we're just going to return that the path is deleted successfully. That's it. So, and the next command is the put command. So to put, we need three arguments, that is the file name and the path we are going to put, where we are going to put it, and k. So I have used a global variable count over here, so that like whenever we are creating new partitions, the count is keeps on updating and there is no redundancy. So if the name is going to be same for two files, the count is still going to be unique. So to just get over that redundancy, I have used this. And I've created a data frame for the file that we have to insert. And then there's just a try and except that I have put, so that if there is no file, it would not throw an error. So now what I've done is I have divided this data frame into k partitions, and then I have created chunks for this, like list of data frames, which have been divided, like 5 data frames, 6 data frames depending on the partitions that were required. And then I'm going to add each chunk using the patch over here into the database. That's it. Um, Next one function is the get partition locations. So get partition locations, as we have seen, that it will return all the partitions of a particular file. So we are storing the, as we can see, like we are storing the partitions in the data node. So what we are going to do is we are going to our database and we are going to check for that this path. Again, since while we were saving it, we could not use the dot, and we replaced it using mod dot mod. Therefore, again, while looking for the partitions, we'll again have to do the same thing, and then we'll send a get command for that particular path. And if that exists, if this is none, then we'll simply return that there are no partitions. Otherwise, we are going to create the list of locations, and we're just going to run through all the r.json items and append all the locations and return them. Next is the read partition. So for the read partition, what the read partition does, it reads all the contents of a file of that particular partition. So first we'll again look for the dot, and then we'll replace it with mod dot mod, since that is how we are saving it. And then we are going to find the partition number, and then we are going to send a get request that if that partition exists or not. If that partition does not exist, we simply return that the partition number is incorrect. Otherwise, we will use the cut command to send the partition number, and we'll save it in a data frame and then convert it into a CSV format, and then return that CSV data. So, and the next command is the cat command. Cat command is used to display all the contents of the file. And since we are saving it in multiple partitions, therefore we need to get all the partitions. So we'll use get partition locations to get all the locations of the data frame. And then we are gonna read through all the locations and then just add it to the data frame. And since we need to append all the data frames, so we need another data frame list, which is going to append all of these data frames. And finally, we will convert it to a CSV file, and then we'll simply, if this df list is equal to null, that means there was no file there. Otherwise, we are going to convert the df that finally we got into CSV data and then return it. So this is how all of the commands have been implemented. So next is the search functionalities that I have implemented. So in order to implement the search functionalities, the data set that I have used is the New York cab data set. So it has the following features: the transaction ID. So the transaction ID is the ID of the transaction that was made by the customer that when he booked the when he paid for the cab, and then the customer ID of the customer who took the cab, and the date of travel, when the customer, the date when the customer took the cab, and the company, like which cab company did he prefer, the pink cab or the yellow cab, and the city, in which city did he book the cab, and the kilometers traveled. So for the search functions, I have used two search functions. The first one is the search function that lists all the transactions that were occurred between a range of date for any particular cab company, the pink one or the yellow one. So this function, it takes two arguments. Sorry, this function takes two arguments: the cab company, date from, and date to. I'm sorry, it takes three arguments. That is cab company, date from, and date to. And search to is to list the cities where a particular customer booked a cab using the customer ID. So first we'll see on the UI how this is going to work. So the first search functionality, which returns the transaction IDs, is this, and we'll select a pink cab company, and we are going to give a date as 2016 0801, and then I just simply copy pasted here, and then this is just for 2 days, and this end of August in 2016, and we're going to submit it. So these are all the transactions that were made in between these two dates, and we can verify it since we can check that all the dates are within the range, and the cab company is pink, and these are this transaction ID that we required, transaction IDs that we required. So similarly, we can check for the second second search, which is like displaying all the cities that a customer had booked the cab. So when we turn this, so there's no data found because this might not be a valid customer, or if customer, or if it is valid, then that customer did not book a cab yet. So we can do another one here. So we can see that this cab, there are two like IDs. That means this customer took cab twice in Dallas, Texas. So this is how the search functionalities are working. We can also see how this happens in the code. So this is the code. This is the code for the getting the transaction IDs. So what's happening is, first, since we need to check for this check for the transaction IDs in all of the partitions. So we'll first of all get all the partitions using the get partition function that we created earlier. And then I've created an empty data frame, and there's a DF list. So now what I'm going to do is I'm going to send a GET request to each location, and it's going to send me some data, and I'm going to store that data in a data frame, and then send that data frame to this map partition get transactions function, and also the arguments that I got, that is a cab company, date from, date to. And then in the map partition function, I'm going to check for the condition, that is if the date is between the date from and date to. Then I'm going to save all the rows that are between these two dates, and I'm going to check if the company is the cab company that the user has requested, and I'm going to put all of this data into a data frame, and then I'm going to return it as an output right here. So since we are doing this for all the partitions, there are going to be multiple outputs, so we need to append all these outputs in a list. So DF list is a basically a list of all the data frames that has been returned by the map partition get transaction, and now we need to combine all these data frames, and therefore we are going to use the reduce get transaction function and send this data frame list right here, and we'll remove all the columns that we do not need, and we're going to return the final data frame over here. So this is going to return us the final data frame, just like this, just like the one we got when we checked in the UI. And this is the second search function, the search function which returns the city that a particular customer has booked a cab in. So this is going to be similar, like we'll take all the locations of the partitions of that file, and then we are going to make a data frame, and then here the map partition get city would be different because our query is different. So the query is to check the customer ID, and since there's just one argument, we need to just pass the customer ID, and over here we'll just check that if the customer ID is equal to the customer ID the user has requested for, then we're going to take the city value for that particular row, and then we are going to create a data frame out of it and then send it. Now again, since we are working on all the partitions, there are going to be multiple data frames, and hence we need to append them all, and finally send them to the reduce get transactions. And if the data frame is empty, that means like there was no data that was discovered, so we'll simply return no data file. Otherwise we'll concat all the data frame list and send the final data frame right here. So since we checked for this customer ID and we got these particular two cities, they were similar cities but it can be different. So this is what we discovered. So my learning experience. So while implementing this particular project, I got a hands-on experience of implementing EDFS, and hence it gave me a better understanding of the structure of EDFS. And I implemented MapReduce while implementing the search functionalities, and I had a better understanding of how the MapReduce works in the Hadoop data structure, and what does mapping means, like mapping a data to all the partitions, and then how the reduce functions combine all the data that has been received from all the partitions and then return them to the user. And second, I also worked on Firebase. Therefore, I had a better understanding of accessing and say storing the data in a Firebase. And since I used the tkinter package from Python, and I never worked on that before, so it helped me like learn about the tkinter library and how the desktop applications can be created using the tkinter library. So that's all. That was my project, and thank you so much.